Let's go ahead and go over 1.1. This top section here, you don't need to do anything. That's just for notes if you wanted to take extra notes. This section down here, this is where the homework is. In this one, all we have to do is just get the letter by itself. It's just a single step. So we're going to put a box around the letter that we're trying to solve for, and anything outside the box, if you remember, inside the box is always times and divide. Everything outside the box is always either plus or minus, and that's how we get rid of it as well. So we're outside the box, which means we have to use either plus or minus. If we use plus, then that 4 will get bigger, it won't go away. So I'm going to use minus. And you can also remember it's always the opposite of whatever it says to do. So minus 4 from both sides. And we're left with W equals 12. And remember, you need to show your work in every single assignment. Number 2, here we have X. Okay, and there's nothing inside the box that we need to worry about, but besides that, we have to get everyone away from the box first, so we have to empty everything outside the box. And here it says plus, so I'm going to do the opposite. I'm going to minus 7, again, always from both sides, and I'm left with just X on that side equals negative 12 minus 7 is negative 19. Here, and we include the sign in front of it. Sorry for that extra little line there. Here we have a negative 15. What's the opposite of minus 15? Plus 15. Plus 15. And you see why I'm getting rid of, that plus right there, why I'm keeping that with the W. So that goes away. And here I have just a positive W, or W equals 6 plus 15 is 21. Now I started saying it, I don't think I finished it. Right here I'm keeping this W plus with the W so I don't get it confused over here. Okay? If I were to minus a negative 15, well, that's the same thing as plus in this situation, but that positive goes with the W. That has nothing to do with that negative 15. So that's why it's important to make sure that the plus stays with, or the sign right in front of the variable stays with the variable. Okay, here I've got the variable, the unknown, including any signs in front of it. There doesn't happen to be any. What's the opposite of minus? That would be plus 5. And that leaves me with just Z on one side, and this goes away, and I'm left with 13 on this side. Here I have the unknown with any symbols in front of it, not behind it. We don't care about behind it, just in front. What's the opposite of minus 9? That would be plus 9. We do it to both sides. And that leaves me with just Y over here. Minus 9 plus 9 give me 0, so that goes away. And negative 2 plus 9 is 7. Positive 7. Now in this one, everything inside the box is included with a multiplication and division. Just like here, if we look at the problem, if it's connected to the variable using a multiplication or division, then it goes inside the box. If it's connected to the variable using any kind of addition subtraction, it's outside the box. So when we look at this, we see right off there's nothing outside the box. So we don't need to worry about the box in that case. We can open it right up. Now we're inside the box, and we do the opposite of whatever it says to get rid of that. Right now it says 7 times Q. Well, 7 times Q, the opposite would be divided by. We do it to both sides, always both sides. And we see here we've got factors on top. The 7 and the Q are both factors. They're times. If there's a factor on top and bottom, they're common. We can get rid of it. It's the same thing as 1. So that leaves us with just Q equals 35 divided by 7 is 6. Okay, here, if we imagine the box, okay, I'm going to draw it right here. Everything inside the box has to be connected, either multiplication or division. That 4 times B, that's connected with multiplication, so we keep that inside the box. There's nothing connected with addition or subtraction, so we're going to have nothing outside the box, which is what we want. So there's nothing out there. So now we find the factors that we need to cross off to cancel out. We have a 4 times a B. I want that 4 to go away, so I want to be able to cross off that factor. And there's the times. And 4. And so we're left with the factors that we wanted to cross off. And 52 divided by 4, or negative 52 divided by 4 should be about negative 13. Okay. Now in this one we start dealing with fractions. Well, anything or any fraction that's included with the variable, so the variable in this case is the Q, it's inside a fraction. It happens to be in the numerator, but it's in the fraction. Anytime a variable is in the fraction, just automatically put the whole fraction in the box. Okay. Now, is there anything outside the box that we need to get rid of with plus or minus? And the answer is no. So now we look inside the box. We have to do the opposite of whatever it says, and any fraction is always a division problem. So the opposite of a division problem is times. So we're going to times by 11, times by 11. Now when you multiply a fraction, the first thing you want to do is extend the fraction line. The multiplication only ever takes place on top. But if we stop and look for a second, we can say, hey, that's Q times 11. Those are factors. We've got a factor of 11 on the bottom and a factor of 11 on top. So those go away, leaving us with just Q on that side. And 11 times 3 is 33. And our final one with just the numbers, and then we've got 2 story problems. Again, everything in the fraction, the n is part of the fraction, so the entire fraction goes inside a box. Everything inside the box we get rid of either multiplication or division. Everything outside the box is either addition, subtraction. There doesn't happen to be anything outside the box, so we're going to just include what's in the box. And I'm going to get rid of this so I have a little more room. Now, whatever it says, we do the opposite. So here it's saying n divided by negative 2. Well, the opposite of divided by is times negative 2. Both sides times negative 2. And if you remember, when we multiply in a fraction, the number just stays on top, so it's the same thing as negative 2 times n. But now if we see we've got a factor on the bottom and the top, so we can cross off those factors, leaving us with just n equals negative 15 times negative 2 is a positive 30. Okay, now that's how you do numbers 1 through 9. Numbers 10 and 11 deal with story problems. A coupon subtracts $17.95 from the price P of a pair of headphones. So let's just write that down. We know that P minus $17.95. Okay, we don't know if there's more to that or if that's even useless information, but we're going to write it down so we don't have to try to remember it. The coupon subtracts $17.95 from the price, so price minus $17.95. You pay $71.80. Well, if you take the price minus that, that's going to equal how much you pay, so $71.80 for the headphones after using the coupon. Write and solve the equation. Well, we've already written the equation. Well, the final price has to be that much more, right? Because that's how much the coupon was. So again, we can look at it like this. We can say, hey, here's our variable. So we're going to add $17.95 to get it by itself. Everything inside the box is multiplication or division. Everything outside the box is addition or subtraction. So plus $17.95. And let's just look at this now. We've got P. This goes away. Equals. Then we've got 5. That's going to be 17. Carry the 1. Okay, now we've got 7 plus 1 plus 1. That's 9. And 7 plus 1 is 8. So the original price is $89.75. And we can always check that and say, hey, what's $89.75 minus $17.95? Is that this price? And you should see it is. Alright, now after a party you have 2/5 of your brownies left over. There are 16 brownies left over. So we know that 2/5 and 16 are talking about the same thing. The same number of brownies, the same brownies. But that's 2/5 of our brownies, and of always means times. 2/5 of our brownies equals 16. Now what did I say about multiplication involving a fraction? Well, that's always on top. So it's as if the fraction bar went like that. Okay, so we'd have 2 times b over 5 equals 16. All I did was put the b on top where it belongs. So if you multiply a fraction times anything, that anything automatically goes on top. Unless it's another fraction, then you got another thing. But if anything whole number goes on top. Well, let's get rid of the fraction. So times 5 times 5, and that gives you a factor that can cross off, and that leaves us with 2 times b, not 6, 2 times b equals 80. Now we're going to divide both sides by 2, and that leaves us with b equals 40. Now if we remember, b is the amount of brownies that we started with, so that's how many brownies we made for the party were 40. Okay, another way to think about this is just times. So what's the opposite of times? Well, the opposite is divide. How do you divide by a fraction? You times the reciprocal. And you get the same answer. So these cross off, and you're left with b. And 15 times 6 divided by 2 is 40. I just took the long way around. So that's how you do the homework. If you have any more questions, let me know. Hopefully that helps. That's 1.1.